go on looking at question 10 now, and I've got this picture in front of me, and I notice that I've got two functions and I've got 2 points of intersection A and B. And I know that to find those 2 points I'm going to solve these two equations simultaneously. So I'm going to make 10x minus x squared minus 8 equal to 10 minus x. And I'm going to rearrange that. That will give me 0 equals x squared minus 11x plus 18. And I'm going to factorise them. So I've got 0 equals x minus 2, x minus 9. Giving me two solutions. X is 2. Let's have a look what y is. So let's plug it into here. I've got y equals 10 minus 2. So that will be a 0.28. And have a look at my other solution. X would be 9. Again, plugging it into here. Y equals 10 minus 9, so that's 1. So 0.91. So my points A and B I've found, 2, 8 and 9, 1. So A is going to be 2, 8 and B is going to be 9, 1. So now I've got the problem that I'm trying to find the area of R. And I'm noticing that this area is bounded by this straight line here and also the curve with the function here. Now, loads of ways of doing this, but probably the sharpest way, the quickest way certainly, is to think about this as being a trapezium here. So I drop my height to the trapezium, and I think to myself, yep, that's a trapezium. If I can get the whole area underneath that curve, between A and B, right to the axis, I can take away this area of the trapezium here that I'm shading now, then I'm going to be left with region R. So the first thing I'm going to do is get the area of the trapezium. So I remember that the formula for the area of the trapezium is the sum of the parallel sides, A plus B, multiplied by the height, and divided by 2. So the parallel sides are here and here. So this one has got a height of 8, and this one's got a height of 1. The height between those two sides is this length here, so the difference between the x-coordinate of A and the x-coordinate of B. So that length there. That's going to be 7, because I've got 9 and 2. So work that out, half of 9 times 7. So I've got an area of 63 over 2. So that's my area of the trapezium. I'm now going to get the area of the curve between A and B, because that will give me the full area from the curve right down to the x-axis. I'm going to get that by integration. So I'm going to integrate 10x minus x squared minus 8 with respect to x. Now my limits are going to be A and B. So my upper limit is going to be the value of x at B, so that's going to be 9, and my lower limit is going to be the value of x at A, so that's going to be 2. So I integrate that. My limits are 9 and 2. So I've got to remember something here, that when I put my limits in, I put my upper limit in first, and then I take away my lower limit. And when I do all that on my calculator, I get 266 over 3. So how am I going to get my full area R? I'm going to get the area under the curve, which is 266 over 3. And I'm going to subtract the area of the trapezium. So 266 over 3 minus the area of the trapezium, which is 63 over 2. And overall, that's equal to 343 over 6.